The basic or the classical methods of food analysis. These are the traditional techniques widely used for many years to determine the composition and the quality of the food products. These are typically based on straightforward on the chemical and the physical principles. These classical methods forms the foundation of the food analysis and widely used today, especially in the regulatory and the quality control laboratories. More modern and the automated techniques have been developed. These basic methods remain essential for their simplicity, reliability and the historical validation. In food analysis and testing, today we are going to discuss about the basic or the classical methods of food analysis. In this we are going to discuss about the classical methods of food analysis. Today I am going to explain about the determination of the moisture content. It is a fundamental aspect of the food analysis. Moisture affects the shelf life, quality and the stability of the food products. In classical food analysis, there are several methods to determine the moisture content, with the oven drying method being the most common. In this we see the direct methods. Determination of moisture methods. In this we see 4 methods. Drying method. In this oven drying methods are used. Distillation method. In this we see the Dean and Stark method. Next is the chemical methods. In this we see the Carl Fisher and the gas production. And next is the physical methods. Next is the drying method. These methods rely on measuring the mass of the water in a known mass of the sample. In a known mass of the sample, we need to measure the mass of the water. The moisture content is determined by measuring the mass of the food before and after the water is removed by drying method. Basic principle is water has a lower boiling point. We know that water has a boiling point of 100 degrees centigrade than the other major components within the food, such as lipids, proteins and the carbohydrates. In lipids we have the boiling point that is around 173 degrees to 227 degrees centigrade, whereas proteins the boiling point is around 542, that is for tryptophan. For carbohydrates we have 182 to 160 degrees centigrade boiling point, and because of the lower boiling point, water evaporates fast. So by drying method we can remove the water. In drying method we see the oven drying method. It is a classical technique used in the food analysis to determine the moisture content of a sample. It involves heating a food sample at a specific temperature to evaporate water and measure the loss in weight. And the principle behind the oven drying method is the moisture in the food sample is evaporated by heating, and the weight lost is used to calculate the moisture content. There are different types of ovens. In this one type is the convection oven. Here greater temperature variations occurs because hot air slowly circulate with the aid of fan. Air movement is obstructed further by the pans placed in the oven. In this it uses a fan to circulate hot air evenly around the food. Then it ensures a faster and more uniform cooking or baking. Forced draft oven. The least temperature differential across the interior, that is less than 1 degree centigrade. Air is circulated by a fan that forces air movement throughout the oven cavity. The drying period is 0.75 to 24 hours depending on the food sample and its pretreatment. Actually it is similar to the convection oven, but specially designed for the industries or the laboratory purposes. It forces air circulation to control temperature more precisely, so it is used in the laboratories. Next is the vacuum oven. Drying under reduced pressure, that is 25 to 100 millimeters of mercury. It is able to obtain a more complete removal of water and volatiles without decomposition within 3 to 6 hours. It removes air from the chamber to allow low temperature drying, often used for delicate samples in labs or for drying heat sensitive materials. Microwave oven. Weighed samples are placed in a microwave oven for a specified time and a power level, and the dried mass is weighed. And it uses the microwave radiations to heat food by exciting water molecules. It results in the quick and the uneven heating, primarily used for reheating or the cooking simple meals. In microwave oven, Water evaporation is due to the absorption of the microwave energy, which causes them to become thermally excited. Advantages is it is simple method, and disadvantages is care must be taken to standardize the drying procedure and ensures that the microwave energy is applied evenly across the sample. Next is the infrared lamp drying. The principle of drying is similar to the microwave oven. This is rapid and inexpensive. This is because the IR energy penetrates into the sample of the food. To produce consistent results, one must control the distance between the sample and the IR lamp and the dimensions of the samples. And IR drying methods are not officially recognized for moisture content determination because it is difficult to standardize the procedure. Next one is the moisture analyzer. It uses a digital balance. The test sample is placed in an aluminum pan and the constant temperature is applied to the test sample. Here, instrument automatically weighs and calculates the percentage of the moisture or solids. The principle of the oven drying method is simple. The moisture in the food sample is evaporated by heating and the weight lost is used to calculate the moisture content. Next, coming to the procedure. First, we have to prepare the sample. First, weigh a clean dry dish or a container. We have to take it as W1 and place a known quantity of the food sample in a dish and weigh it again, that is W2. Next is the drying method. Place the dish with the sample in an oven, set a specific temperature, usually 100 to 105 degrees centigrade, and dry the sample until it reaches a constant weight, indicating all moisture have been evaporated. This usually takes several hours. Next is the cooling and weighing. Remove the dish from the oven and cool it in the desiccator to prevent moisture absorption from the air. Weigh the dish with the dry sample, that is W3. The moisture percentage of a sample is calculated by using a formula, that is moisture content in percentage is equal to initial weight minus final weight by the initial weight into 100, where initial weight is the weight of the sample before drying and the final weight is the weight of the sample after drying to a constant weight. The formula can also be expressed as W2 minus W1 minus W3 minus W1 by W2 minus W1 into 100. It is simplified as W2 minus W3 by W2 minus W1 into 100, where W1 indicates the weight of the empty container. W2 is the weight of the container plus the weight of the wet sample. W3 is the weight of the container plus the dried sample. The amount of the moisture in a product is given on the basis of the weight of the water present in the product and it is usually expressed in the percentage. Moisture content is designated by two methods, that is wet basis method and the dry basis method. Wet basis. The moisture content in this method is represented by the following expression. Moisture content in percentage is equal to weight of the water in the product by the weight of the product sample into 100. Dry basis is, it is given by the basis of the dry weight of the product, that is weight of the water in product by weight of the dry matter of the product in sample into 100. Here we can understand it properly. What is wet basis? The moisture content on the wet basis is obtained by dividing the weight of the water present in the material by the total weight of the material. Weight moisture content by the wet basis method is equals to, this is the weight of the water present in the material by the total weight, that is water plus the dry matter present in it into 100, where WW is equals to weight of the water in the material, where WD is the weight of the dry matter in the material. Next is the dry basis. The moisture content on the dry basis is obtained by dividing the weight of the water present in the material by the weight of the dry matter of the material. Moisture content dry basis is equals to weight of the water by weight of the dry matter into 100. Before we saw the weight of the water plus weight of the dry matter in the wet basis method. Here we only see the weight of the dry method in the denominator. WW is equals to weight of the water in the material and WD is the weight of the dry matter. Relationship between the dry basis and the wet basis moisture content. Moisture content on the dry basis percentage is equals to moisture content wet basis percentage by 100 minus moisture content wet basis percentage into 100. I will say you how it came. Let us assume this total matter of the food sample is 100%. In this, some percentages of wet matter and some percentage of dry matter. So, we write it as wet plus dry is equals to 100%. When we want to calculate only dry percentage, we have to move this wet that side, that is 100 minus wet percentage. Then we get the dry matter percentage. Here we know the formula, that is moisture content dry basis percentage is equals to, we know that WW is the water percentage. So, we write the moisture content in the presence of wet basis percentage by the WD is the dry matter. In that we write it as 100 minus wet percentage, 100 minus moisture content in the presence of wet basis into 100. Now, we need to cross multiply this. After cross multiplying this, moisture content dry basis into 100 minus moisture content wet basis is equals to, this moisture content wet basis which is in the numerator is multiplied with this 100. Next, the moisture content dry basis into, we need to multiply this into 100 minus moisture content dry basis into moisture content wet basis is equals to moisture content wet basis percentage into 100. As we want the wet basis percentage, we need to transfer this moisture content dry base into moisture content wet base to the right side of the equation. So, this minus turns to plus. We need to take the wet basis as common, then we get 100 into moisture content dry basis is equals to moisture content wet basis percentage into 100 plus moisture content dry basis. Here 100 into moisture content dry basis, we need to bring this to the down, so that we get the wet basis percentage, that is 100 into moisture content dry basis percentage by 100 plus moisture content dry basis percentage. We got the wet basis. We have derived this wet basis from the dry basis method. So, we get the moisture content dry basis percent by 100 plus moisture content dry basis percentage into 100. The value of the dry basis moisture content is more than the wet basis moisture content. Now, we will calculate some problems, so that once see the calculation steps. Determine the initial weight, that is wet sample, and measure and record the combined weight of the container and the wet sample, that is W2. Dry the sample. The sample is dried until a constant weight is achieved, indicated that all the moisture have been removed. Determine final weight, that is dry sample. Measure and record the combined weight of the container and the dried sample, that is W3. Compute moisture content, that is subtract the final weight from the initial weight to find the weight of the moisture lost. Divide the weight of the moisture lost by the initial weight W2 minus the weight of the container, that is the W1, to find the fraction of the original weight, that was moisture. Multiply by 100 to convert this fraction into percentage, representing the moisture content of the sample. In this we see the first problem. If a sample weighs 50 grams initially, that is W2, and 45 grams after drying, that is W3, and the container allowing weights, that is 5 grams, that is W1, then the moisture content is calculated. We know that the moisture content formula, that is W2 minus W3 by W2 minus W1 into 100. So, we need to put these values here, 50 minus 45 by 50 minus 5 into 100. So, we get 11.11% moisture. Now, coming to the second problem. A sample of the food weighing 50 grams is placed in an oven for the moisture determination. After drying, the weight of the food sample reduces to 40 grams. Then calculate the moisture content of the food sample. The formula is initial weight minus final weight by the initial weight into 100. That is 50 minus 40 by 50 into 100. We get the 20% of the moisture content in the food sample. And the third problem is on the dry weight basis. You have a food sample that contains 30% of moisture. What is the percentage of dry matter in the sample? The dry matter percentage can be calculated by, the dry matter percentage is equals to 100% minus the moisture content percentage. they have given the moisture content percentage. So, we need to put this here. 100 minus 30 percentage is equals to 70 percentage, we get the dry matter in the sample. Next is the moisture content on wet and dry basis. A food product has a dry matter content of 45 percentage. Calculate the moisture content on both a wet basis and the dry basis. They gave the dry matter content, that is 85 percentage. We need to calculate first on the wet basis. Moisture content percentage is equals to 100% minus dry matter percentage. We got the, they have given us the dry matter content. So, we need to put this here. 100% minus 85% is equals to, we get 15 percentage on the wet basis. Moisture content on the dry basis is equals to, formula is moisture content on the wet basis by the dry matter content into 100. We got the 15 percentage on the moisture content of wet basis. So, we need to put here 15 percentage by the dry matter content is already we have given it, that is 85% into 100. We get 17.65 percentage moisture content on the dry basis. Next is the oven drying method. A food product weighs 200 grams before drying and 170 grams after drying. What is the moisture loss in grams and the moisture loss in percentage? Moisture loss in grams, the formula is initial weight minus final weight, that is 200 grams, that is before drying, minus after drying, that is 170 grams. We get the 30 grams, that is the moisture lost in grams. The moisture content, that is in percentage, is equals to moisture lost by the initial weight into 100. How much moisture is lost here? That is 30, and the initial weight before drying, that is 200 into 100 is equals to, we get 15 percentage of moisture content in percentage. Next problem is 2 tons of paddy with 22 percentage of moisture content on wet basis is to be dried to 13% moisture content on dry basis. Calculate the weight of the bone dry products and water evaporated. Weight is 2 tons given, that means 2000 kilograms. Moisture content on wet basis, it is given as 22 percentage. In order to get the dry matter, we need to remove the wet matter from total 100 percentage, that is 100 minus 22, we get the 78 percentage of dry matter. In the total weight, we need to calculate the dry percentage, that is 78 by 100 into 2000, we get the 1560 kilograms. Now, we need to calculate the moisture content in the presence of dry basis. We know the formula, that is moisture content wet basis by 100 minus moisture content in the wet basis into 100. We know that the moisture content is given, that is 22 percentage. It is substituted, 22 by 100 minus 22 into 100, we get 28.2 percentage, that is of dry basis. Now, the 22% moisture content on this wet basis must be dried to 13% moisture content on the dry basis. So, water is evaporated, we get 1560 into 28.2 percentage minus 13 percentage, we get 237.2 kilograms. The amount of dried product is, the total weight is 2000 kgs minus 237.2 kgs, we get the value 1762.8 kgs. This is the amount of the dried product. What are the advantages and limitations of oven drying? Advantages are simple and widely used and applicable to the wide range of food products. Limitations are time consuming, requires drying to a constant weight, and not suitable for samples containing volatile compounds, because when we dry them they evaporate, or the substances that may degrade at the drying temperatures, and potential for incomplete drying if the temperature is too low, for decomposition if the temperature is too high. The oven drying method is a fundamental and the reliable technique for determining the moisture content in the food products. Despite some limitations, it is commonly used in the quality control in the food processing industry. If you like the video, please do like, share and subscribe.